the active time of I-ADOPT was in 2019 to 2021. And we are now officially in maintaining mode, but actually we are as active as always. And we started already in 2018 because I had to work for the Environment Agency Austria to actually provide a vocabulary on observable properties, but not only for lots of stuff on the ELSA network. And I wondered how to do this, and I tried to find out how other people are doing this, how other infrastructures are trying to achieve some harmonization in this chaos. So I decided to go to RDA and create a working group. Yeah, we are quite successful, I would say. 23, we had, no, 22, our recommendations were endorsed by RDA. So, so it's not it's our work. And we updated of the FAIR principles, and we promote the reuse of their terminologies. What we want is to provide a fair, systematic approach to type variables, enabling mappings to a common representation across terminologies. And we provide rich human, but also machine impossible descriptions using qualified, and that's the I3 principle of the FAIR principles, qualified reference. So using terminologies that are us, and this is all possible without the need to change existing terms and structures. So this is the challenge. There are tons of vocabularies out there describing our data, research data, observation data. And these terms or concepts are called variables, parameter, properties, whatever, but we don't know what we mean by the different instances exactly, because we can just guess, because it was never really precisely done. So we look at the what is observed, not on the where, not on the how and the when, because for all these other specifications exists, so we don't want to replicate or do something new, although it exists already. And actually, we were focused on observation and measurements, but it will be used for simulations, for calculations, for aggregations, at the moment also for aggregations. That's learned, I would say. And we are inspired by different other language ontologies and Asian attempts to do this, like the complex property model and the scientific variable ontology, where Stolka was involved in. So generally, when we observe, we have just simple properties. We observe something like this long sentence. I am not going into detail of this. It's a long sentence. We try to not look at the process, not look at the feature of interest, which is important, yeah, but not for our model. We look at the yellow part and we decompose them in different parts. And then we decided not to include the units because the units are important as well, but a variable can be expressed in many units. We didn't because we have now the statistical modifier included, something new we added. But for each of these atomic parts, we have to search for semantic artifacts or concepts from semantic artifacts. That is an umbrella term for ontologies, thesauri, whatever, yeah, ontologies that are hopefully fair and have their identifiers. And we can use actually any of them. You can build your own vocabulary just for doing this. It's not very wise, but good. And then you describe these different parts with this semantic artifacts. So the recommendations that we published are simple. We say both human and machine readable information, meta information about what we observe. This description must be explicit, it's sufficient. we use semantic artifacts therefore, and best to use I-ADOPT aligned terminology, but it is somehow different. But to be recognized by spatial theories, it is important to say that your term is a property or an entity in terms of I-ADOPT that you are using. So these terms are then used for describing your variable. So very briefly, a property is property. Actually, it's width, length, whatever. But this is sometimes too little information, so we need to add some context. And the contextualized property is an I-ADOPT variable. So we can say an I-ADOPT variable consists for sure of a property that we have additional description components. And this description components can be of various natures, but there are entities for sure that we are using here. And these entities can have different description goals. They can be an object of interest. They can have the role of an object of interest, of a matrix, of a context object. And in addition, we also allow these entities to be constrained. So this is the whole core model. It's actually simple. Simple for ontologies for semantic experts, not so simple for domain experts. I'm quite sure that this is sometimes very challenging. In addition, it became a bit more complex. So I don't go into each of the details, but we allow also for EBVs, essential biodiversity variables, or essentially Gaussian variables, or essential whatever variables. So sets of variables that for that we can use the Barbara set. That's just to say, can also make groups of all this. And we have made some improvements for those that already knew I-ADOPT. Well, we had workshops earlier this year, and we found out that there are gaps and some bottlenecks, and wanted to address them, and therefore we extended the ontology. So we extended it by the statistical modifier, because we said, okay, me is an aggregation, right? You need different observations to put them together. But people have limitations, so we cannot just focus on the raw data. We have also to go to the aggregated and be able to describe them easily. Okay, we added that. So it's a property as a has statistical modifier that is linked to the variable directly. And then we have also allowed constraints to not only constrain LPTs, but also statistical modifiers and properties. So this makes the description language much more flexible. Okay, so explained in a more easy way, but not correct semantically, you could say, okay, we have we have these different entities having different roles, but we could also translate it in this way. Like, oh, it has an object of interest, it has a matrix, and it has a context object. And this is actually the preferred way that people want to use it. So they want to say, oh, I have a box for all my object of interest. I have a box for all my matrices and so on. That would be nice, but actually does not fit perfectly into the model, because depending on the observations, these roles can change. And water sometimes is not only the matrix. It's also really the object that I want to focus on in my observation. But let's go a step before. So you need the property at least one, and you need an object of interest at least one, and the object of interest has intrinsically this property that we want to describe. Indirection, very easy for non-professionalists, but it's just two words. Yeah, we can say, oh, direction is the property and the object of interest, but actually, if you are climate expert, you would say that's not enough. You would have to add much more. But just to say, there is much more complexity in the reality, and we always try to simplify when we describe. So one level deeper, so a level of water, of lake. Yeah, how could we do this? yeah, the property is the level, the object of interest is the voucher, and the context object is lay. Actually, if it is the matrix or the context object, is a bit arbitrary, depending how you see it. If you say level of water in lake, probably it's the matrix, but that's not so important for the moment itself. If you want to add constraint, level of stagnant water, you can do it like this. You add stagnant as a constraint, and this constraint constrains the water. But if you want to be more precise, also to add an additional information about the level, where do you measure it from? Then you have to define the baseline, and you add this as a constraint to a property. So here you have a bit more complex information, so it gets always more complex. I'm not going to a very complex level at the end, just showing what is possible. Temperature of the air in the height of 1.7 meter. Daily maximum, so we introduced maximum, so a statistic modifier with maximum, and daily would be the constraint on the statistical modifier. The constraint 1.7 above ground is a constraint on the air. Now we introduce another complexity because we found out, well, life is more complex as we think. We have also something like a system. So entity is not something, only one thing, it's complex as well. So there can be systems, and the systems can be symmetric or asymmetric. And if it is symmetric, it has different parts that belong to, and then these two object properties that are linked to these parts are the same, therefore they are symmetric. Asymmetric, then they have different roles in this description. An application for that, for the symmetric, is, for example, to have a line of intersection. You define the different planes that play a role in this system, right? That has part decomposition. Much more important in ecology, we have asymmetry, so we have fluxes. We need to be able to describe fluxes. So we have the asymmetric system here from vegetation to soil for the mass flux of carbon that goes from vegetation to soil. So we have the source and the target. This is object properties are just important for semantic experts and not important for the domain expert because they would call it probably differently. But we have to use predicates for these relations, therefore we have used that. So you see, it's not easy, although it's actually a simple ontology. So what we did is in the challenge. Last year we did the challenge, tried 2 challenges, 30 variables. We asked lots of experts to submit ideas what we should challenge against. So we had a common set of variables, and we invited people to model this. Some were very eager and modeled all the 30, others 10, but it was a very interesting experience. And we found out, well, there are different ways to do this. And some of these are correct, some of these are preferred, and some of them are wrong. But it does not matter. It helped us to find out the bottlenecks of this framework. And also that we need to develop a semi-automated I-ADOPT variable analysis. Well, I knew that from the very beginning, because nobody would do this like me, like sitting hours and hours modeling, because that's not feasible. So we need a service that supports us, right? For this, many people already found it interesting and really already started to adopt before I did it, for instance, in other vocabularies like actress, the actress vocabulary for all the atmospheric variables. ICOS was also discussing this to use a French Oscar vocabulary, etc. Many already used it before we were totally convinced about it, and now it's even more. It went a bit viral. Everybody is speaking about I-ADOPT. Anyway, the German NFI is now going fully I-ADOPT. All their data networks are flying it. And I'm saying slow because we have to provide a stable basic for it. But it actually really helps to clarify data and data, not only metadata, because you could describe your CSV files and NetCDF files with this. I'm finished in 1 minute. But we need also verifying metadata to manage semantic artifacts and harmonize data integration. So we made other two workshops to really go into the deep problems of representation of variables, and we had many people, and I had to make two workshops because we had too many guests. So we have people from ELTA, Actis, NASA, coming from the US, although they were like pre-invented, some of them couldn't come. Anyway, we were happy to have two of them meet us with WMO Vibers. Half people came to risk assessment group, and we had a project called I-ADOPT MHCI for Earth project, the German project. These people from I-ADOPT and MHCI for Earth, they are working now together to develop this annotation service. So we found out we need rules for alignment between OMS, observation, measurement, and sample. And Kathy was there instrumental to say that this is needed. We need to find alignments between OMS and I-ADOPT to find out how the feature interest links to our observed property or the decomposition of the observed variable. We need modeling methods, and we need to extend the ontology, which we did, end of May. And now we have this collaboration. We have refined all the challenge variables. We agreed on a new modeling, and we have examples with what already people can see and learn from. And we have a visualizer. You put in your area, and you get out this visualization, which is very helpful. But now, what is really on our agenda is this annotation service, which is LLM based on LLM enabled placement patterns that I'm developing. And the idea or the ideal solution is, as researcher types into what he or she observes, the system recognizes it, decomposes it, annotates it with semantic artifacts, visualizes it, expresses it in machine-readable output area, and at the end also maps it to existing variable descriptions, because there are so many out there that are similar for problem at once. Thank you for your